So now let's look at general differential equations here and what makes a solution. So a solution here is just a function that works in the equation. So you take the function, its derivatives, you plug it in, and they work. So here's an example. Let's say that we want to show that every member here of a family of functions, y equals c1 plus c2 e to the 2t is a solution of y double prime minus 2y prime equals 0. So they call this a two-parameter family of functions because c1 and c2 are unknown constants. They're parameters. They could vary, be any real number. So first thing we do is start finding derivatives here because we're going to plug in here. So y prime, you differentiate c1, you get 0. Differentiate e to the 2t, you get e to the 2t times 2. So that derivative is 0 plus c2 e to the 2t times 2, which is 2c2 e to the 2t. Do another derivative. Your y double prime then is going to be, you differentiate this e to the 2t, you get e to the 2t times 2, and then your 2c2 out in front. So 2c2 e to the 2t times 2, or 4c2 e to the 2t. So now I want to plug y double prime in here and y prime in here. So plugging into that equation, your y double prime minus 2y prime is going to be y double prime right here. Plug that in. Minus 2, and then here's your y prime. So I brought that down and plugged it in. But then this is going to be 4c2, and then negative 2 times 2, negative 4c2. So these guys are just going to cancel out, and we get 0. So it works in the equation. So that shows that every function that's in this two-parameter family solves, because notice it didn't matter what c1 and c2 were, because everything ended up canceling out. So we show that infinitely many functions are solutions at the same time. That's pretty cool.